Hello students, today we'll be going through the 2014 TYS free response question. Let us now go ahead and look at question 8a. Sodium oxide is classified as a basic oxide and carbon dioxide is classified as an acidic oxide. Name two other types of oxides. In the chapter Acids and Bases, we have learned that there are four different types of oxides, namely basic oxide, acidic oxide, amphoteric oxide, which reacts with both acids and bases, as well as neutral oxide, which does not react with either acid or base. Moving on to B part 1, draw and label the electronic structures of carbon dioxide and sodium oxide. Let's first look at carbon dioxide. Carbon dioxide has the chemical formula CO2. Since both carbon and oxygen are nonmetals, the bonding present in carbon dioxide is covalent. Carbon is a group 4 element with 6 electrons. So a group 4 element has 4 electrons in its valence shell. As you can see, there are only 4 electrons in the valence shell for carbon. Hence, carbon requires 4 more electrons to complete its valence shell. Next, oxygen is a group 6 element with 8 electrons. A group 6 element requires 2 more electrons to complete its valence shell. And as you can see from in the oxygen atom structure, there are 6 electrons in its valence shell. Hence, it requires 2 electrons, which will come from carbon. Hence, carbon will share 2 electrons with the oxygen atom, and likewise, the oxygen atom will share 2 electrons with the carbon. So that will be a structure for CO2. Moving on to sodium oxide, the chemical formula for sodium oxide is Na2O. Sodium is a metal, while oxygen is a non-metal. Hence, the bonding in sodium oxide will be ionic. Okay, so sodium is a group 1 element. Hence, it has 1 electron in its valence shell, correct? So to achieve a full valence shell, sodium actually has to donate this 1 electron to oxygen, giving us the full valence shell in sodium, as you can see. 8 electrons in its valence shell. Since sodium has donated 1 electron to oxygen, it will have a plus charge. Next, for oxygen, as we have mentioned, oxygen is a group 6 element. Hence, it has to accept 2 electrons from sodium to complete its valence shell. This will give us a 2 minus charge on oxygen. However, as we know, sodium can only donate 1 electron. So where will the 2 electron come from? This is why the chemical formula is Na2O. We actually need 2 sodium to donate 2 electrons in total to our oxygen. So this will be the formula for this will be the structure for sodium oxide. Okay. After finish drawing the structure, please do not forget to write your legend. It is very important to have your legend. Moving on to B part 2, use these structures to explain why, at room temperature and pressure, sodium oxide is a solid and carbon dioxide is a gas. As you can see from the above structures, carbon dioxide has a simple molecular structure, while sodium oxide has an ionic lattice structure. Since carbon dioxide forms covalent bonds, the carbon dioxide molecules are held by weak intermolecular forces of attraction. Thus, little energy is required to overcome these weak intermolecular forces, and it has a low melting and boiling point. Thus, carbon dioxide exists as a gas at room temperature and pressure. For sodium oxide, it is held together by strong electrostatic forces of attraction. Thus, a lot of energy is required to overcome the intermolecular forces, and it exists as a solid at room temperature and pressure. Let's look at the marks allocation for question 8. So for part A, 2 marks are being allocated to part A. So 1 mark will go for amphoteric oxide and another mark will go to neutral oxide. For part B, part 1, 4 marks are being allocated since we are drawing 2 structures here. So 2 marks will go to the CO2 structure and 2 marks will go to the Na2O structure, giving us a total of 4 marks for B part 1. So lastly, for B part 2, first of all, we have to state the structure for CO2, which is a simple molecular structure. That will be 1 point. And Na2O, ionic lattice structure, there will be another point. Next, we will link the forces and the melting and boiling point to the molecular structure, giving us another point. So we talk about the intermolecular forces, the melting boiling point, and the state at which it exists. So that will be 1 point. And likewise for our sodium oxide as well. So that will be a total of 4 points, 4 marks for your B part 2. And that is all for question 8.